Welcome to the next installment of the Train Vicar. Today I'll continue the mini-series on railway practices that are seen as difficult or impossible in one country and are quite normal or possible in another. And today I'll look at level crossings. Yes, railways can offer frequent services on lines with many level crossings. Most railway lines in New Zealand have many level crossings. They are quite common. Level crossings are the riskiest parts of New Zealand's railway system. Most accidents, injuries and fatalities occur on level crossings. They are also quite costly, requiring barriers, bells, signalling and constant maintenance of the surface. In addition, trees may need to be cut back, or more costly earth moving or engineering required to ensure visibility. That's all a bit much for level crossings which have very few trains and some with very few cars, cyclists or pedestrians. That's why there's a risk-based model requiring higher safety specifications for level crossings that have more trains, faster trains or more road users or faster road users going across them. That all seems to make sense, but it has created some issues. For example, it's planned to have more trains between Palmerston North and Wellington in 5 years' time. Well, because there will be more trains, some level crossings will have to be upgraded. Here in Christchurch, a cycleway was built near a level crossing. With more potential users, that level crossing had to be upgraded. The many level crossings in Christchurch have also been raised as an issue for any future suburban or regional rail services. In Auckland, on the Western Line, the number of trains will be limited because the line has too many level crossings. KiwiRail has a standard which determines what safety features a level crossing should have. This is informed and reliant on the New Zealand Transport Authority's Traffic Control Devices Manual, Part 9, Level Crossings. This in turn is dependent on ALCAM, the Australian Level Crossing Assessment Model. This model calculates a risk score. The risk score is calculated by calculating the infrastructure factor, multiplying that by the exposure factor, and multiplying that by the consequence factor. There are various complex assessments at the base of that, but very important is the road volume and rail volume. The more trains and cars are expected, the higher the risk factor. All this makes upgrading a road, building a cycleway, having a train stop at a station, or increasing frequency quite difficult, as level crossings may need to be upgraded. Well, in Switzerland I know a railway line with many level crossings and high-frequency train services. It is the line between Worb and Bern, operated by Regionalverkehr Bern-Solothurn, RBS. It's particularly the section between Bern and Bolligen. Here, trains operate every 7.5 minutes in each direction during the peak. That is about 8 times per hour. And yet, there are several well-used level crossings on this railway line, along with a few sections of single line travelling. These level crossings are, of course, frequently closed. Maybe they don't have quite so many cars travelling across them, but certainly a lot more trains and pedestrians than most New Zealand level crossings. And yet, the safety features are not more elaborate. The closing times before the trains arrive are just as long, if not longer. Now, Switzerland has similar standards as New Zealand to assess level crossing safety. With higher risk factors, the more trains or road users there are. But it seems that the safety requirements are not quite as stringent, with high-frequency railway lines not requiring particularly onerous level crossing signalling. But of course, in Switzerland now, all level crossings have to be secured in some sense. So for low-level crossings, the requirements are actually higher. Now, that might be because for a country with so many railway lines and level crossings and such dense train traffic, accident rates are actually quite low. If you consider that many level crossings in Switzerland are near stations and used by pedestrians, that's quite remarkable. Because there's always the temptations for pedestrians, or particularly for passengers, to try and beat the level crossing to catch a train. But I suppose if you know that the next train will be along in 7 or 15 or 30 minutes, it's not quite as disastrous if you miss that train. To understand why, with so many trains and level crossing accidents are so low, I want to look at one really serious accident that was very important when I worked at the Federal Office for Transport there. In 2014, a group of Israeli tourists decided to take a photo of a waterfall and crossed a non-signalized level crossing. The van they were in collided with a train. 3 people died, 5 were seriously injured. Now, one risk factor was that the level crossing had no light or barrier. But probably the greatest risk factor was that the people in the car were not from Switzerland and were not used to level crossings. While trains in Israel have become a lot more frequent in recent decades, there are practically no level crossings in that country. Lines are fully grade separated. Now, together with the distraction of the waterfall, the lack of lights or barriers, it was that the tourists were not really expecting the train that caused the accident. The more people expect the train, the more trains are part of normal life, the more people act normally around them. In Switzerland, for example, the bus stops and bus services are planned with level crossings in mind. Here on the RBS, there is a direct connection with a bus which does not require passengers to go over the level crossing. So it's best practice not to just design for the level crossing, but take the wider environment into account where people have to walk or drive. Back to New Zealand. The paradox is that the actual risk may decrease as more trains operate on a certain line. That's because people will actually expect the train and are familiar with trains. I still remember travelling on the standard railcar in the South Island. Somewhere near Rangiora, the railcar had to apply the emergency brakes as someone did not stop at a level crossing. Not many trains travel on this line during the day, and so people were not used to stopping and seeing a train there. But if there is an expectation of regular trains, people are more careful around crossings. So, contrary to the formula by which risk is calculated, the exposure factor actually seems to lower the risk factor rather than increase it. But of course, the tendency of engineers is to rigidly stick to formulas. I think that needs to be checked against reality. And that reality is a lot more complex and it involves a lot more contradictions than formulas can capture, especially if humans are involved. That this world is infinitely more complex and that human motivation often is difficult to capture is something we always need to remember. That's so in many spheres of life. I've experienced it myself. In my first year of university, I also studied physics and was recognized for my outstanding achievement in the subject. But I did not continue with it. Well, one reason was that I needed some more mathematics to take physics at a more advanced level. I did take those mathematics courses, but by then I had also studied theology, and with it the deep and probing questions there. And so those questions in theology seemed so much more intense, so that physics, in a sense, seemed somewhat simplistic. Of course, by now I realize that physics is more complex at a higher level, but I think that we should never forget the human dimension and the deep mystery of this world, which Christians believe is revealed in Jesus Christ, to the extent that humans can grasp it.